Right then, this is a little review of the work I've been doing on block detention, detecting locomotives with various sensors. I'm just showing you here a few of the sensors that I'm using. This one is the IR sensor, which is also on this board here. This is a phototransistor. These are just reed switches. Obvious difference in size between the IR sensor and the reed switches, and you can see the photoresistor is quite small. Now, so we're driving, I've shown you a video of this before, so we're driving the relay to switch, trigger the relay when the IR sensor detects an object, which we do now, and it turns on the relay, which switches the contacts over to the LED. Okay, so that's pretty good, and you can change the sensitivity of the IR sensor. One of the problems with the IR sensor is that it won't detect black, okay, which is the color, or reflect from black, which is the color underneath our locomotives. So there's a problem there. Showing you the circuit diagram already for that, but just maybe a quick look at that, gone through it. Okay, the next thing we have now is the circuit with just a phototransistor and an NPN. I've gone through this before, but just a quick review. Again, it should be dark activated, so it turns on the LED. Like, it's almost kind of dark in here at the moment, so it's a bit lighting up as it is. It's quite sensitive. That can be adjusted slightly with the resistors. Again, that's the circuit diagram, and I've done a comparison of those two circuits in an earlier video. So that's your phototransistor, dark activated. Again, I need to be kind of, you see it's quite sensitive. The whole problem with that is that the sensitivity, the output from the transistor, if you like, in this case is actually, it's the collector that gives the output. It's quite a low current, it's not enough to drive a relay. Now this next setup here is using a Darlington pair arrangement. So if I cover the phototransistor, you've got the LED on. That's off, like so. Now that's been driven through a relay. So the Darlington pair arrangement allows for greater current effectively. I'm just going to pause here for a second while I disconnect. So a bit more discussion on the Darlington pair. We have phototransistor here. That's a PNP transistor. That's an NPN transistor. Then we're going through the relay here, and then we're on the common, normally open contact, so when it switches it goes normally closed, so it turns on the LED, and that's what we're showing. Now this is the circuit for the Darlington pair. Pretty much what the photoresistor does is turns on this first transistor, which gives an increased current in this direction, and that feeds the base of the NPN transistor and gives an increase in current here. So we're kind of, if you like, amplifying the rather weak current that comes from this circuit here, which is this voltage divider circuit here, which is giving very small currents, current gain, if you like, through the it's the collector in this case. So the Darlington pair effectively amplifies not only the base current, but then here we've got the collector current goes into the base, and then we amplify the collector emitter current that's up around 60-70 amps, depends, and is driving the relay to switch. couple of tricky things with this. We have a bit of time to get this sorted. It's a bit overly sensitive. It depends what ambient light conditions are, but it doesn't care whether it's black or white. You know, it just needs to be dark. I'm running the relay direct, not quite with this diagram here. I'm running the relay off 9 volts. Just needs that little bit extra kick with the battery going through all this electronics here. So it just needs a little bit of extra kick to actually to drive it and trigger the relay successfully. So that's pretty much it. That's your Darlington pair arrangement with a phototransistor to drive a relay, and of course then the relay would be switching on and off the circuit to your power line, to your locomotive or whatever. That's it. Thank you.